Hey guys, I'm going to read to you today the article that is assigned Beyond the Boom, How 4th of July Fireworks Displays Are Made. Just like before, I will read the article and then afterwards I will flip over and read the questions which are on the Google slide for you guys to fill in. All right, here we go. Fireworks were invented long before the United States used them to celebrate its independence. Sometime between the years 600 and 900, two Chinese scientists accidentally mixed the chemical mixture potassium nitrate with sulfur and charcoal. Legend says that they were trying to create a drink that would help them live forever. Instead, they created a crude gunpowder. It was the first known example of a firecracker. Many different chemicals are mixed. Fireworks were first just exploding bamboo tubes, said John Conkling. He's the former head of the American Pyrotechnics Association, a group that supports the fireworks business. Pyrotechnics is the art of making fireworks. The Chinese got more and more creative over time, Conkling said. They realized that by adding other minerals, they could make the explosion different colors. The simplest firework has three ingredients. It needs an oxidizer, a fuel, and a chemical mixture to produce the color. An oxidizer is a chemical that allows the fuel to burn. Often, it is oxygen gas. Over the years, scientists have staged various chemical reactions to produce different colors. When different elements burn, they shoot out light at different wavelengths. Each wavelength shows us a certain color. For example, the elements of lithium and strontium carbonates produce deep reds and purples when they are burned. Copper chlorides make blue. Titanium, aluminum, and magnesium are silvery. Calcium chloride is orange, sodium is yellow, and barium burns green. Copper burns blue but cannot get too hot or too cold. Because of this, blue is the most difficult color for firework experts to create. The final release of energy. Electrons are tiny particles found in all forms of matter. When they are heated, they gain energy. Then when it cools down, the leftover released as light with a certain wavelength. A firework is ignited by lighting a main fuse. This kicks off the chemical reaction inside. The flame travels through the lift charge, which sends the firework upward. As it flies through the air, potassium nitrate, charcoal, and sulfur start to burn. They heat the main casing around the firework. When the casing explodes, pellets containing the chemical color mixtures fly out. They release light as they fall to the ground. This produces the glittering fireworks we see. In the old days, someone with a torch would walk along the lines of fireworks, Conkling said. They had to be lit one by one. That meant that fireworks displays were limited by how fast the guy could run, Conkling said. Most fireworks today fire electronically, which means that all you have to do is push a switch. Okay, I'm going to flip over to the questions now. So just like before on this Google form, what you guys need to do is fill in your name, make sure that you hit your core, because this automatically will grade itself and it will, we can filter it into Echo. So make sure you guys hit your core. All right, question number 1. Read the section, many different chemicals are mixed. Which sentence from the section shows that some types of fireworks are more challenging to produce than others? They realized that by adding other minerals, they can make the explosion different colors. Over the years, scientists have staged various chemical reactions to produce different colors. Each wavelength shows us a certain color. Copper burns blue, but cannot get too hot or too cold. Question 2. Which paragraph in the section, the final release of energy, best supports the conclusion that producing a fireworks show could be dangerous? Paragraph 7, paragraph 8, paragraph 9, or paragraph 10? Question number 3. Complete the sentence below. Overall, the article is organized around an explanation of why fireworks explode and produce different colors, a problem that scientists had creating colors in fireworks and how that problem was solved, a comparison of fireworks long ago with those made today, a description of important events in the history of the development of fireworks. All right, last question. Question number 4. Read the 2 paragraphs from the section, The Final Release of Energy. When the casing explodes, pellets containing the chemical color mixtures fly out. They release light as they fall to the ground. This produces the glittering fireworks we see. In the old days, someone with a torch would walk along the line of fireworks, Conkling said. They had to be lit one by one. That meant the fireworks displays were limited by how fast that guy could run, Conkling said. Most fireworks today fire electrically, which means that all you have to do is push a switch. Which answer best describes the structure of these 2 paragraphs? Both paragraphs have a comparison structure. The first paragraph has a problem and solution structure. The second paragraph has a comparison structure. Both paragraphs have a cause and effect structure. The first paragraph has a cause and effect structure. The second paragraph has a comparison structure. Okay. That's it. Remember that you guys can replay this. So when it asks you to go back and look at the paragraphs, you can go back to the reading and you can re-listen to any parts of this. We will be online on Zoom, me 9 to 11 and Ms. Bosnango 1 to 3. If you guys have any questions.